Maybe not more than 20%. Okay, the bulk is the 2D Mohr circle. The fundamental foundation is with 2D Mohr circle. Okay. Now let's look into 3D Mohr circle now. Okay. Now 3D Mohr circle. Okay, so let's look at 3D. Okay. So for 3D Mohr circle, right, I'm going to sketch out in 3D. As you know, this is your X, Y, and Z. And the face with the biggest area. Right. Right. So this is an element. So in 3D Mohr circle, you have three stress state. Okay, so you usually have your stress X, you have your stress Y, and then you will have somewhere over here is your stress Z. Okay, so this element is orientate, right, at its principal plane. Right. So therefore, the shear stress in any of this is equal to what? You don't see any shear stress at all. Okay. So we are going to follow the orientation of this element now. Okay, we're going to follow the orientation of this element now. So let's look at there's going to be three conditions. Okay, so condition number one. I'm going to use because I need to construct Mohr circle, I'm going to use the graphing mode. Okay. So condition number one is where stress X is greater than stress Y. Okay, both are tensile. Right, and stress Z is equal to 0. So for this case, we have a plane stress condition. Right, we happen to have a plane stress condition. Okay, now before I go on, we know that this surface over here, just to remind you, this is our XY plane, and this is our in plane. Over here is your YZ plane, and this is your out of plane. And the last one over here, this is your XZ plane. And this is where is your out of plane also. Okay. So now we have condition number one, where stress X is greater than stress Y. Both are tensile. Okay. And stress Z is equal to 0. Okay. So now I'm going to sketch this condition. Okay. I'm going to So this is our normal stress, right? And over here, this is our shear stress. Okay, so this is 0, normal stress. Over here, this is our shear stress. Element rotate clockwise, element rotate anti-clockwise. So we know that stress Z line is equal to 0. So this is our stress Z line. And then we know that stress X is more positive than stress Y. Right. So this is our stress X line. Right. And then this is our stress Y line. Okay. So this is your stress X line. And this is your stress Y line. Okay. So we know, again, we will label like what we had before. This is your point X on Mohr circle, point Y on Mohr circle, and point Z on Mohr circle. So we know that this is your point X, and you know that this is your point Y. So the first circle that we're going to draw is this circle over here. Okay. So because it touches point X and point Y, I'm going to label this, right? This belongs to your XY plane. And it's your in plane, right? And that's the circle that we make. And then we know that this is the tau max. Okay, this is the tau max. Okay, for your XY plane. Okay, for your XY plane. Okay. We also know that over here is your stress Z. Right. So now if we join the YZ points, right? I'm going to use a different color now. So now over here, because it touched YZ, right? Now this is your what? YZ plane. And this is your out of plane. And we know that the maximum shear is at the tip here, right? So we know that over here, this is your tau max YZ plane. Now there's another circle that we can draw is your XZ. Your XZ. Okay. So your XZ is here now. And I'm going to change to blue. And you realize that it has the biggest circle. So it touches point X and point Z. Now over here, this now is on your XZ plane, and this is your out of plane. And what we realize now, right, if we look at this now, is the out of plane has the highest shear stress. Right? You know this out of plane, right, has the highest shear stress now. So we know that this is your tau max for your XZ plane, and it is the absolutely biggest tau max. Okay, and you realize that it's at its out of plane. Okay, so when we draw this now, okay, before I go on any further, some of you might ask me, Eugene, why when it join XY, we call it XY plane? And then why when we join YZ, we call it YZ plane? Okay, so I'll explain to you that, because sometimes students get confused. Okay, X, Y, Y, Z, Y is that. Okay, they can get confused. So if I were to draw the element on the XY plane, if I draw the element, so if I were to draw the element on XY plane, right? So it is a square. We know it looks like this, right? So if I were to draw our transformation, this is our X and this is our Y, both are tangent. Right? This is our point X, this is our point Y. When we draw a circle, we call it our XY plane. Okay. So now when we draw our YZ plane. Okay, so I'll draw our YZ plane. So now this is our YZ plane, right? That's our YZ plane. So this is our YZ plane, right? So this is, so our Y has a normal stress Y. Our stress Z is equal to 0. So this is our point Y, and this is our point Z, right? So when you join Y and Z together, this is your what? Like what I told you, we are looking at your what? We are looking at the Y Z plane, right? That's why when we draw this circle, it belongs to the what? YZ plane. And then the last plane that we have is our XZ plane. Okay, our XZ plane. So on XZ plane, I'm going to draw it this way now, right? Right, so our XZ plane, so this is your X, right? This is our X, and this is our Z, and we have our stress X, and stress Z is equal to 0. This is our point X, this is our point Z, and that when we join both of them together, that's where we call XZ. When we join all the circle together, that's where we call our XZ plane. And this is how 3D Mohr circle look like. It's not any more difficult than 2D, isn't it? 2D is the worst. Okay, once you come to 3D, it's not so bad. Okay, so for this condition, as you can see, right, as you can see, the maximum stress, shear stress, sorry, occurs